Is it doing the thing? Oh, here we go. Is it doing the thing? Oh, here we go. Alright, I'll make sure to post this link on my story. And a couple servers, and then we'll start. Is it doing the thing? Oh, here we go. Alright, I'll make sure to post this link on my story. And a couple servers, and then we'll start. Sounds good. And let's put a link here. Link YouTube. Alright. And let's also post that link over here. Here and convolution. All right. Let's restart the session. So stuff has been going pretty well. Besides, I would honestly say how do I say it? I would honestly say that the prompts haven't been great. So I'm gonna check what people are talking about the prompt before I start. See if it's a poor one or not, and if I need to make any adjustments. But yeah. So first let me check the Triton puzzles repo right here. See if there's any comments on 10. Change the index var k to L to avoid confusing with the kernel k. K pointer, Z pointer, N0. Kind of looks the same. See if they say anything in GPU mode server. Okay, look in Triton puzzles. Look up 10. I think it's fine. All right. Come back here, see where it's at. Oh man. I forgot to do what I did last stream, which was make sure that the stuff was actually running before I started, so sorry. Hopefully it won't take too long. Maybe let's read in the meantime, right? Here we have our two-dimensional convolution. It says we want to do a batch 2D convolution. Use one program ID axis. Block size B0 represents the batches to process out of N0. Image X is size H by W with only one channel, and kernel K is size KH by KW. So this is a kernel, KH by KW, H by W. It's not clear to me what the stride should be. B0 represents the batches that process out of N0. So let's look at our spec. We have our out, we have our in, which is a 4 by 8 by 8. So we have 4 batches, it looks like, and then 8 by 8 image. And then we also have our kernel, which is 4 by 4. And we're outputting to a 4 by 8 by 8. So it's the same as the input. So we're gonna pad with, what is this, zeros? input in pad. Hmm. One, two, three, four, five, six. Value equals 0. I'm not sure what this is doing, actually. The pad. And let's see if this is done also. I believe so. Yeah, so let's restart our session. And run this. So I have a 4x8x8 grid here. Looks like 4 channels, each with an 8x8 spatial grid. Yep. But really, we should be thinking of this as 4 batches, each with 8x8 spatial grid with 1 channel, right? I think that's what it said. Let's see if this is running. Looks like it. Yep. So it's coming down here. Batches, 1 channel. Yep. For 3D inputs, pad interprets the tuple starting from the last dimension and moving backwards. So it should be BHW, but we continue. 0, 4, pad the last dimension. Add 0 on the left and 4 on the right. Pad second to last dimension by adding 0 on the top and 4 on the bottom. Pad third to last dimension by adding nothing, which makes sense. So effectively each 8x8 slice grows to 12x12, yep, but the number of channels stays at 4. Resulting say 4x12x12, and then in the loop we're gonna aggregate each of these little 4x4 things, I think, right? Like right here, I have for I in range 8, for j in range 8, so each new position in my output z, I'm gonna take the, what would this be? What is k? Oh, it's our kernel. I can take my kernel, multiply it by a piece of the row I'm in and a piece of the, well, we're doing all the batches at the same time here, right? So we're doing each of the little patches sequentially, where we're just multiplying them by the kernel and then adding up the rows and columns. But and then writing that into Z. Alright, I think this makes sense. And then when we parallelize, what are we actually doing? So it says we want to look at block size B0 represents the batches of process out of N0. So I think the idea is just that all of these are being written to main memory each time. So instead, what we're gonna do is what are we gonna do? A little confused here. B0 is 1. What do I actually want my threads to be on? X pointer, K pointer, Z pointer, and 0. Really, what would be more ideal is calculating each convolution independently, right? Well, let's just try doing it across B0 for now, and then we could see about also parallelizing little 2D parts. Really, that's what makes sense though, is to do the little 2D parts, and it honestly make more sense to do them one batch at a time. That would be faster. I'm gonna look at what they use for the offset. Yeah, offset I. Because this is what I would do, right? Well, I don't want to cheat. Look at the impl, so I'm gonna just interpret this as though we're supposed to parallelize across the batches, and then make changes to it later. So first thing to do is gonna be look at our batch offset, right? Which should be TL.A range 0 to B0 plus PID 0 times B0, and our B mask is just going to be that the B offsets need to be less than and 0, right? But we're not gonna load in our entire batch, obviously, because N0, H, and W are not const expr. But what are const expr are the dimensions of our kernel. So let's load in our kernel, right? I'm gonna say K offsets equals something. Really, I need Ki offsets equals TL.A range 0 to K H. Let's call these KH offsets, right? And same thing for KW offsets. And then my K offsets will be the KH offsets plus the KW offsets. right? So let's make this a column vector, and this one a row vector, and this just sort of give us like a grid. Then we can just load it in, right? We can say tl.load k pointer. Sorry, just get back. We're gonna load in our k pointer plus our k offsets. We also need to do a k mask. It's actually not clear to me we need to do a k mask. This should just be the actual size, right? So I'm gonna just leave it like that. And this should be our k. Maybe I'll call it kernel, right? Now we can do our loops, right? So we could say for h block in tl.range 0 to h, how big of a chunk do we want to do this in? I think we want to visit every I think we want to visit every position, right? So this is what I was talking about, where it's like we should probably be using the parallelization axis to do one of these versus this, because this is probably the least intensive part, right? We only have, let's say, 4 batches versus, 8x8 grid. That means we're doing 64 convolutions here, but I'll deal with it later, right? First thing would just be excuse me, to grab this, right? We want this piece. So what we need to do is we need to get I here, J here, and then we'll say our X mask equals, now we need to do a 3D read. So what we need to remember, right? So what we've been doing is we've been we've been doing this sort of like 2D masking here. I think, I'm getting confused because I feel like we're doing it on the wrong axis, but like it's hard for me to tell because the problem description is a bit vague. Because wouldn't you want to do two? Is there another one, right? Quantized matrix result, matrix multiplication. No. Wouldn't you want to parallelize with two axes, right? You could map each ID to like a kernel, right? But then what would you be using the B0 for? Same thing going on over here. This is confusing me a little bit, but let's keep it going, right? We want our X chunk. We want our little X block, right? It's gonna be TL.load X pointer plus, I don't know, I'm gonna call this IJ offsets for now. And I also want my IJ mask. And then we're going to do this operation right here, right? So we might say our conval equals this, right? And then we need to do it right. We need to say TL store Z pointer plus IJ offsets our conval with our IJ mask like this. And then I think that's it, right? So instead of this, I'm going to replace this with block. Instead of this, I'm going to put that over here, right? Because we're doing the same thing every time. So I'm going to say kernel times X block, and we're going to say TL.sum, just like this. Get rid of these. And now I just need to write these offsets, right? So to load in my X block, what do? Oh, I need to make sure I pad correctly as well, but I think it'll be fine. I just need to make sure that when I load this in, I replace it with zeros, which is what the load already does. So I'm going to say I offsets equals what? I might be able to reuse this too, right? using my K off. I might be able to just use my K offsets. Isn't that what I want? That's why this is 4 plus 4. So maybe let's just call this my X offsets instead, right? Or just offsets even. What do I want? I want each row to be the batch. Then I want 3 axes, right? I want the batch numbers, which I have right here, my B offsets, right? Then I want another axis that, well, let's just think about the what I want in this grid first, and then I'll think about it in batches, right? But so what I want is each row starting from I, so I want my I offsets to equal I plus the KH offsets, like this, right? And then for the J offsets, similarly, I want to start at J and then go over KW. So I'd say J plus KW offset. Then I want to put these properly into a 2D grid, right? So I would say I would do what I did here. The I offsets and the J offsets, and this gives me my 2D little piece, right? This gives me my IJ offsets. But I think I need to think about this a little bit more because I have a batch that I need to accommodate for, right? Also, right here, I need to make sure that I skip like all of the rest of the row, right? Like if I'm doing this little 2x2 piece, I want to skip these. So I need to multiply in my, it should be my width, right? So if we printed this, we should sort of see the correct thing, hopefully. Let's try that maybe actually, right? And for the IJ mask, I need an I mask, which says that the I offsets needs to stay less than the height. And I also need a J mask, which says that the J offsets stays less than the width. And then our IJ mask is going to say that each of them together, like this, right, satisfy our conditions in a 2D grid. So there should be a mask, there should be a mask, just like that. This isn't quite gonna work yet, right? Because we were doing something 2D and 3D, but let's try it out first. Just see what gets printed, right? It should be a 4x4. Looks like I have a 1x4. Really? Or 4x1. What's up with that? Let's print KH and KW. It's 4x4. What's up with that? Oh, I see what's wrong. This should be like this. And so should all the rest, right? Let's try that one more time. That looks more like it. And yeah, we're sort of getting what we want here. Yeah, this looks right. 0, 8, 16, 24, 1, 9, 17, 25. Yeah. So now we need to just grab the right piece from the batch and also write the right piece back to the Z pointer. And then we should have done our convolution. And then we can explore better parallelization schemes than the one we're writing, right? Let's see. So when I have 3D, I'm gonna have to do something like this, but multiply even more, right? Like this has a secret factor of 1, then this has a factor of W. When I add the third term, it's gonna have a third factor, like it's gonna be B offsets times W times H plus I offsets times W plus J offsets times 1. Kind of wonder if there's like a, so I could do it explicitly, or I could like start with this, multiply by H, add this, multiply by W, let it distribute over, add this, multiply by 1, and so on. I think I'm just gonna write it explicitly, right? Like we could just say over here, we can just put our Bij offsets equals B offsets times H times W plus here, and then we need to expand each of these a little bit differently. Now it's not a row and a column in a row. Now we need 3 dimensions, right? So we'd start like this, and then like this, and then like this. And we can get rid of this times 1. Oh man. Then we're gonna combine them in the mask very similarly. We're gonna say B offsets like this. We're going to expand into a third dimension. Do the same thing here. Do the same thing here. And this should be a mask, sorry. Lastly, let's put these in, right? Let's put our Bij offsets and our Bij mask in. Just like that. And I don't know, fingers crossed this just works, right? But I think I'm doing something wrong. Axis 2 is out of bounds for array of dimension 2. This is a 4 by 8 by 8. This is a 4 by 4. This is a 4 by 8 by 8. This has dimension 3, dimension 2. Am I messing something up here? Maybe. Let's see if it's loading in first. Nope. It's in our offsets. Oh, I see the problem. These are each of these are 1D arrays, right? And whenever I keep a colon, that means I'm keeping that dimension, right? So here I'm saying keep dimension 0, keep dimension 1, and then insert a new axis. What I should be doing is I should be putting multiple nones, right? I should be saying keep the first axis, insert 2 new axes, and so on, right? I just need to make sure I do it in the right order. So I need to think about this carefully. This is going to be kind of difficult for me. I think we want to keep the rows, right? And then we would do the opposite of what I did here. We would keep the middle, and we would keep the end like this, right? And I'd also need to do this with my mask. See how that goes. Name IJ offsets is not defined. Where is it seeing IJ offsets? Oh, right here. Let's also get rid of this print. Let's see. It looks like some of it is coming out correctly. So we need to adjust our access pattern, right? This means I'm either indexing wrong, masking wrong, or like mixing up dimensions or something like that. Let's see. Mm. Mm. B0 will be 2, 1, 2, 3, 4. 4 batches. Let's try printing our X block here. And see what it says. So it looks like I have a 3D list. I have this 2x2 piece in it, which is what we want. Like this right here. See if this is the same as what's in the actual input. Oh my gosh, come on. So many loads and writes. See, this is sort of strange. We have this row of truths for each batch at the end. There is something interesting here. When I'm writing to Z, I only want to write Z-I-J, right? I-J-K. What I don't want to do is write a whole piece. I only want to write a little individual item. So this should be like sort of, when I'm getting my X block, I should be getting a patch, versus when I write Z, I should be writing the individual item that the kernel returned, right? Well, yeah, I got the individual item here, but then this, I'm not even sure how this is getting written correctly, right? Like, really, this should just be a single item. This should literally just be Z pointer plus I times something plus j in the batch, right? Like this should just be b PID. This should just be the B offsets. Let's see. Let's say our Z offsets equals this, and our Z mask equals this, right? Z offsets is going to be our batch, so our B offsets times H times W, but then all we want to put here is what? We just want to put in I and J. But we need to make sure that this is a W, I think. Right? I have my little row of batches, and then this seems correct to me. And then for the Z mask, is there anything we need to do? I think no. Besides maybe that our, our B mask is correct. Right, like we just need to say B mask do we even need to this does need to be 3D though, right? So we do need to put this just like that. But then I think this can stay, which also means our Z mask needs to have the B mask be expanded. But we could just do it like this. Let's replace that with a Z. And let's put our Z offsets here. This might be just completely wrong, but gotta give it a shot. Torch at size 4x12x12. I'm gonna get rid of these prints. This one. Try it again. What is this? What is getting printed here? Oh, I see. Alright, so I'm probably doing this right to Z wrong. Maybe there's a way I could sort of check in the intermediate. Not 100% sure. None, like that. This is the part that looks kind of sketch, right? Maybe let's try print the BIJ offsets. And I'm gonna put BIJ, right? And print G offsets. And compare them because they should have similar starting indices. So like right here, my BIJ offsets are like this. I don't know, maybe I should print I and J as well. I don't think it matters. I think they should have the same start, and if they don't, there's a problem, right? Because essentially, for each of these blocks, I'm grabbing I and J just plus some offsets, right? But this is just the, like my kernel patch. It should be the same as this. So like right here, 115, 116, 117, 118. These should be the same number. So one of them is wrong. At least if I'm thinking about it correctly, it should be the same number. Why would it be off by 1? I times W plus J. going on there? Why is it not? There's no reason to add a 1, so I don't really understand what's going on there. Need to think about this a bit longer. And we got, and we messed up our rights. Now they're all false, but we'll get it back. Really, I'm more concerned with this. What is going on? Why is this 1 off? Seems strange to me. Times H times W. Plus I this offsets times W. Plus J offsets like this. And really, I'm using a different notation to here, which is probably confusing. I should probably be saying I, J, and K instead of B, I, and J, but it's easier for me to think about, so whatever. I'm still very confused about this. Oh, I'm just looking at the wrong pairs. They are the same. Okay. B-I-J and Z off. I'm just looking at the wrong pairs. So this and this are the same. That's good. That means that this is receiving the right index, at least in theory. So the real question now is just why are the numbers coming out wrong, right? Seems like we're only getting true here. I think one thing that might help clear this up is if height and width aren't the same. I think that would help. Right. So I'm going to turn this into a 2, and I'm going to turn this into a 4, and we're going to run this. And if it messes up, well, then that means, you know, we have like height and width switched or something like that. Yeah, look at this. Doesn't that look messed up? So I probably have this mixed up. This should probably be like, I know the shape of X is going to be V by H by W, right? Which is why I did this. 1 W H W. But maybe my scheme is messed up. What if I just tried that? Did I break everything? Well, it looks worse than what we had. Oh, I didn't switch it everywhere. So let's also switch that one. Yeah, this looks worse. The only thing I can think of is that I have it backwards. I don't really see why. Why is this last row coming out? It also could be the case that my masks are messed up, right? So I should check them a bit, right? Like what is what do my masks look like? Don't we want... Maybe it's not. Maybe that's not strange. This implies we ran out of room on the... on where? I'm gonna put this IJ print at the top to make things less confusing for myself. So like for example right here, we go 6370. We ran out of room on the column end, so it makes sense that we might have falses on the column. And right here, 60, we have true, 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 false, 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 true, 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 false, false, false. These masks look right to me. So what's the implication here? All right. Where's mine? There we go. Oh, I am thinking of it wrong. The Z, no. The Z, IJK. No. Let's see if that really messed stuff up or not. Names. And I'm gonna put I, J, and K instead of B, I, and B. I need to do a, oh, man, I wish I had better internet setup. I need to fix my internet setup for this, but whatever. Really, this Z mask shouldn't even exist, I think. Except for the batch dimension. It's really the only thing to worry about. $127. I do want to see what the actual I don't know, like just print X, and then let's compare that to my first block of X and see if it's loading it in the way I expect. Is that a thing that I could do? Minus 0.0037, 0.2862, no, it's 2682. Minus 0.00044444. And all the way up here. Let's get rid of these. Let's get rid of these. Get rid of this. minus 0.003743441. Minus 0.0037. That's correct. And 268 also looked correct, right? Yep. But then the next row is minus 0.0444, and here it's not. Here it's minus 0.1925. Now I wonder if I could even find that number in here or not, right? Is that this? One, two, three, four. Oh, I might have just messed up the actual. I didn't realize it doesn't accommodate, right? Like, look, we have one list, two list, three list, four list. Well, wait a second. Wait a second. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6, 7, 8. And there should be 4 of these, right? Yeah. I messed stuff up by doing this. I need to just put it back. I thought it dynamically resized, so that actually makes sense that it didn't work. Let's see what the errors are. I feel like the other ones, maybe the other ones I was only changing the block dimension. Yeah. So this is coming out to true. You have 8 by 8. So here I have minus 0.037, 0.268, minus 0.044, 0.1323. Let's see how that looks compared to X. Yep, minus 0.0037, 0.2682, minus 0.0444, 0.1323. That looks correct, right? For like right here. Looks close enough at least. Like it looks like it's floating point errors versus incorrect reads, right? Yeah. How about for the next one over, right? The next one over should just be this but shifted, which looks right also. Did I read my kernel incorrectly? So let's print K. Let's print the kernel. One more thing, I'm gonna put axis 1, even though it really shouldn't matter. Like this should just be a There should just be a number. Yeah, it's just a number. It shouldn't really matter what order I'd sum it in. I just need to sum all of it. Let's see. This is my kernel that I read in, and this is the actual kernel value. Ooh, it looks like there might be something wrong here. Hold on. Four, 9, 5, 5. So this row is correct, but then look, this row is completely wrong. Why is that? It's because for these offsets, I'm not adjusting by kW. So was it just a coincidence that the bottom row was correct? It was. How was that? Well, I do think that means that we've solved it though. Let's try it and see. Gosh, this is slow. This can't be what they meant for me to do. I mean, maybe. I don't know, right? Maybe they're just trying to show us, look, you can keep this kernel in SRAM the whole time. But I don't know, that seems kind of regrettable. Yeah, it's correct. It's correct, but can we do it another way? Can we maybe try to parallelize across? I'm not sure how we would do that though. Let's compare. Let's compare to the reference solution over here. Yeah, it looks like they do the same thing. I mean, is there anything different here? Yeah. Looks very similar. Looks like they kind of just, they save some of these nuns so you don't have to keep doing it over and over, right? And I could also do that. I don't know if it would be worth it. Let's see. Let's see if it makes like a significant difference on the time, right? Because this had took, how long had this took? This took quite a while. Let's see. B offsets, we would go like this. And then for I offsets, we would go like this. For J offsets, we would go like this. And then we could get rid of all this, right? Still seems pretty slow. It seems like the faster thing. Well, it did. It did load a bit faster, actually. Still seems like the preferable thing to do, though, would be to parallelize on the actual convolution writes and reads. But yeah, alright, that was 2D convolution. I'm gonna go to sleep. Post this in my GitHub. Stay tuned for matrix multiplication. Well, one more thing. I will check to see if there's like a solution over here that looks interesting, right? Yeah. Let's put this in here. Let's say V, like that. And let's try running it, right? Let's say source.fem bin activate. Are these broken now? Should I just not even like put them now? It's kind of frustrating. Where are all these letters coming from? Does this solution even work for it? Or are these messed up, right? Let's see if the reference solution works in the actual implementation. Looks kind of broken, man. Well, I'm gonna do what I did last time. I'm gonna just take it off the... I'm just gonna take it off the test list and publish the solution, right? Because I don't really know what's going on there. But I do want to post a solution. Yep. Alright, so we're gonna say git add dot git commit dash m 2d com and git push.